Operations with matrices. ACT loves this stuff. All right, loves it.
Okay, see you later.
Bye. Operations matrices, here we go. Definitions. Whoops, too fast. Okay. Matrix. It is a rectangular array of variables or constants in rows and columns, usually enclosed in brackets. That definition is very, I think, confusing. This will help you out. That's a matrix. Okay. If you started working through ACT prep books, if you've taken the ACT before, you've probably seen at least one question, something like that. All right. So that is a matrix. There's a lot of different things you can do with a matrix. We're not going to get into super details about a lot of them. We will go into details about some of it though. An element is a value in the matrix. Okay, so that's one of these numbers. So this one has 1, 2, 3, 4. Individually, those are elements. Collectively, it's a matrix. All right. And next part, probably the most important part of a matrix is knowing the dimensions of a matrix. Okay, and understanding how they go, because you're going to have a different set of rules to each different operation for a matrix. Okay, so you're going to have a different set of rules to each operation that we're going to do. Okay, add, subtract, multiply, and then some other stuff. But the dimensions of those matrices determine whether you can even do said operation. So it's important to understand the dimensions. Okay, so dimensions are the number of rows and columns in a matrix. Okay, number of rows and columns that are in a matrix, described by m rows and n columns. So I'm going to change this matrix that I wrote up here just a little bit. 1, 2, 3, 4, 5, 6. Okay. So there's our example matrix. 1, 2, 3, 4, 1, 2, 5, 3, 4, 6. How many rows of numbers are in that matrix? 2. Rows go sideways. Okay, rows go across. So 2 row. How many columns? 3. So 2 by 3. And they put that X, just like how if you would go get a 2 by 4 from the store. Okay, 2x4, 2 by 3, 2 by 4, 3 by 4, whatever the case may be. Okay. So 2 row, 3 columns. Dimensions are your most important part to these matrices. If you don't understand the dimensions, or one day you take a quiz or test, you get your dimensions crisscrossed on how they go, sorry to say, it's not going to be a good day, because it is the most important part, okay, and how they work out. Okay, described by m rows, n columns. Rows go first, columns go second. Alrighty? And then we'll get to an example like this eventually. A matrix is usually named using an uppercase letter. You'll see that on 1 or 2 examples today. You'll see, actually a few examples today, and then you'll see that on your homework tonight. Alrighty? Okay, so now this page isn't meant to freak you out because it's a little messy, at least at the onset, but you're going to realize that a lot of these pages and matrices are going to look kind of messy because it's just kind of the nature of the beast here. Okay, but once you realize what you're doing and how they read, it's pretty simple. So we're going to start with adding and subtracting these matrices together. And your rule to add or subtract them together is that they have to have the same dimensions. Okay, so if you're going to add or subtract matrices, they must have these same dimensions. If they don't have the same dimensions, then you can't even do it. Okay, so that's your main rule for these, is if you have 2 matrices that have the same dimensions, you can add or subtract them. The way in which you add or subtract them is very simple. You add or subtract their corresponding parts. Okay, so like if down here in the example, big matrix A plus big matrix B, if A's got these variables A, B, C, D, whatever numbers they may end up being, B same way, E, F, G, H, to add them together, you add this one with this one to make that one, this one with this one to make that one, and then the same for the bottom. This one plus this one to make that, D plus H to make D plus H. Same for subtraction too, except surprise, surprise, it's a subtraction sign in the middle. Okay, so you're literally adding or subtracting the corresponding parts. So from one to the next to your answer, your dimensions don't change. Okay, kind of makes sense. So this one, and that expands to all dimensions, right? They show you the example of a 2 by 2. That same process goes for 2 by 3s, 3 by 3s, 3 by 2s, whatever the case may be. Okay, typically you guys don't go bigger than the 2 by 3s, 2 by 3, 3 by 2, and a 3 by 3. Okay, but it's the same process throughout, no matter what. So. And this is how a lot of, like, if you go real world type, a lot of matrices are set up because it's a lot of numbers to rewrite over and over and over again. So typically they'll write them once, like we do up here, and then we'll give you operations using the letter that they're assigned. So matrix A is 16, 2, negative 9, 8. Matrix B is negative 4, negative 1, negative 3, negative 7. Matrix C, 8, 6. Okay. And then they'll give you the 3 operations. So A plus B, B minus C, B minus A. All right, so start at the beginning. A plus B. All right, so first off, let's go through and get these guys' dimensions. A is a 2-row, 2-column. B is a 2-row, 2-column. And C is a 2-row, 1-column. All righty, 2 by 2, 2 by 2, a 2 by 1. First operation we want to do is A plus B. So 16, 2, negative 9, 8, plus, negative 4, negative 1, negative 3, negative 7. So A is a 2 by 2 and B is a 2 by 2. Can you add these two together? Yeah. All right. And then to do it, you just do the corresponding parts. So 16 plus a negative 4 gives you 12. 2 plus a negative 1 gives you 1. Negative 9 plus a negative 3 gives you negative 12. And 8 plus negative 7 gives you 1 as well. Alrighty. A couple of things before we move to the next one. First off, make sure you this should kind of help you guys get a little organized and work on your spacing and numbers. There needs to be a space between. Okay, make sure there's at least a big enough gap in between that I can tell it's a 12 and a 1. Don't smash it together and make it 121. If you smash it together and make it 121, then I'm taking off. Okay. Secondly, circling your answers here is sort of, I don't want to say difficult because you can always just make a big circle, but it's kind of spacious. You know what I mean? Because you're gonna have to circle the big thing. So I gave you two options. Either A, when you make your final brackets, make them a little darker. Or B, what a lot of people do is just take a highlighter real quick and highlight the brackets of their answer. Okay. I'm not saying either one's required. If you don't do either one, I'm assuming the last matrix is your answer. Okay, whichever one's last in your line of work, I'm assuming that one's your answer. Okay, so just be aware of that. All right, next one, B minus C. B is a 2-row 2-column. C is a 2-row 1-column. Can we do it? No, we can't. Okay, so the word that you're going to see on the worksheets and stuff like that for that one is undefined. All right, undefined. That matrix is undefined. It's not that you can't even start it. It's not like you can start a problem and get to no. That's the difference between no solution and undefined. Okay, and I want you guys to kind of understand that. No solution means you worked it out and it didn't come up with an answer. Undefined means you can't even start. This one you can't even start it. Okay, so that's the main difference. Okay, last one, b minus a, 2 by 2 and 2 by 2. So can we do it? Yes, we can, but I feel like Bob the Builder here in this lesson. Can we do it? Yes, we can. Anyways, make sure you put the matrices in the order they ask. Okay, that's kind of a tricky one throughout. Make sure you do b first, a second. All right, so -4, -1, -3, -7, minus 16, 2, -9, and 8. And once again, go through do corresponding parts. So -4 minus 16. Okay, -4 minus 16 gives you -20. -1 minus 2 gives you -3. Let's do a different color. -3 minus a -9 gives you what? 6. And then -7 minus 8 gives you -15.
Did you write it in a column or what?
Okay, the second kind of operation we're going to learn today, where there's two different types of multiplication that goes with matrices. Okay, one is multiplying the two matrices together. We'll do that tomorrow. We'll actually take two matrices, multiply them together. The one we're going to do today is what is called scalar multiplication. Now, it's a very basic process, but scalar is a word that I will say throughout this chapter. So please understand what a scalar is going forward. Scalar multiplication is when you multiply any constant with a matrix. What is a constant? No, just in general. It is the K on the screen, but what's a constant like when you're working a problem? It's an easy answer.
Stay the same.
Nope. Well, that's being constant. But if something's going to stay the same, put it to a number sense, it's going to stay the same. What? Fill in that blank.
Same value.
Value, which is also known as a
Amount.
number. Yeah. Okay. But I like to say number, right? It's going to stay the same number. Okay. A constant's just a number. That's all it is. Okay. But like Joey said, it stays the same value. 5 is always 5, right? Okay. Now, to multiply a matrix by a constant, okay, so here's the capital letter A, that's your matrix, times it by K, very easy. So K times A, B, C, D, KA, KB, KC, KD. You multiply that number throughout your matrix, and that's all it is. Okay, make sense? Fantastic. Everybody good up here? Moving on. Next one. So, if R equals -12, 8, 6 as your first row, -16, 4, 19 as your second row, find 5R. Okay, so just to show the steps this time, and your dimensions won't change here, right? You're just multiplying -12 times 5, 8 times 5, 6 times 5, 16 times 5, 4 times 5, and 19 times 5. And all you do is then just go through and multiply everything by 5. So -12 times 5 gives you -60. 8 times 5 gives you 40. 6 times 5 gives you 30. -16 times 5 gives you, oh crap, why am I blanking on 16 and 5? Someone help me. I'm seriously blanking. It's 80, right? Okay. Brain fart. Okay, 4 times 5 is 20. 19 times 5, 95. I did everything else fine. What? I don't know what that deal was. Space cadet. All right. Anyways, so if you ever see a number, it'll either be a number next to the capital letter like that, or you might see it. Let me kind of fudge this a little bit. Instead of having say R equals right there, you would have the 5 right there instead, and that means the same thing. Multiply that 5 throughout. Okay. Make sense? Everybody good? I mean, as soon as you understand the dimensions and everything else, it's basic stuff. I mean, you're adding, you're subtracting, you're multiplying. That's really all we're doing this whole unit. 4 lessons, however you want to word it, except it's just when and how you can do it. That's the main thing, okay? Got one more. This one's for you guys. Have at it. So you put the number in front of each matrix. I would show this step just as you guys get the hang of it, but honestly, that's a step you can kind of skip over once you do get the hang of it, okay? Now, I always take the first matrix and just multiply it through, okay? So multiplication goes first, just like how it would be like with numbers and everything. All your order of operations and stuff like that, that all holds true here. So you got to multiply everything first, okay? So negative 4 times negative 4 gives you 16, times negative 8 gives you 32, times 2 gives you negative 8, times 3 gives you 12, okay? Now, the one where it gets a little messy and confusing is the second one. You can do this one of 2 ways. I'm going to show you the way I recommend. All right, first. I'm going to put a minus sign here, and I'm just going to multiply everything by 3. Okay? And make this negative 27, 36, 6, and negative 18, like that. Okay? Just bring the minus sign straight down, multiply it by a 3 through. What's the other way you could do it? Put the negative 3 through instead, and then where my green arrow is pointing to, you would need to put a plus. Okay? Everybody see the differences? I'm fine either way. I just don't. I'm going to consistently do it one way, and it'd probably be this way. But if you want to multiply everything by negative 3, as long as you put that plus there, we good. Okay? Last thing, subtract them or even add them. So 16 plus 27 ends up. So
drop it.
Yeah. So bring the minus sign straight down, multiply everything by 3. Or multiply everything by negative 3, and then put a plus here instead. One of the two. Either one, same thing. You get the same thing, just different signs down here. So 16 plus 27 gives you what, 43? Is that right? Hope so. We're going to roll with it. 32 minus 36 gives you negative 4. Negative 8 minus 6, negative 14. And 12 plus 18 gives you what, 30? Let's see, 27, 37, 43, yeah, 32 minus 36, there's negative 4, negative 8 minus 6, negative 14, 12 plus 18, 30, yeah, cool.